Hi, this is Charity McKenzie with IDEA, and this is a lesson for pre-algebra on distributive property and combining like terms or simplifying an expression. Kind of depends on how they label it. So let's start with the distributive property, okay? And this property tells us, all right, so let me write distributive property. Okay, so this property is going to tell us that if we have something that we are multiplying by something we're adding, so it's going to look something like this. If I have a 2 and I have like maybe x plus 3, something like this here, the distributive property tells me I can take the number outside the parentheses that's being multiplied by it and multiply it by each term inside the parenthesis, and this would equal the same result. So what it's saying is if I take the 2 and times it by x, I'd have 2x. And if I keep the symbol of plus and I go 2 times 3, I would get 6. And it's saying you could take that 2 and multiply it through, and these would be equal to each other. So they're the same thing, it's just a way to simplify and get rid of the parentheses. So that's what the distributive property is, and you use it a lot in a lot of different places. So another example, we could have a negative outside our parenthesis, and then maybe a 2 in, and I could change the letters. I can have all numbers. So I'm going to give you about 5 or 6 examples of the distributive property, and then we'll move on to combining like terms. So if we look at this one, we're going to start with this -4, and we're going to think of -4 times the 2n. Okay, so when you're multiplying letters and numbers, what you do is you multiply the actual numbers and keep the letters. So -4 times 2 would give you a -8. Because remember, a negative times a positive is a negative. And then you keep the letter of n. So when I combined those two, I got -8n. Then I take -4 times 5. So there's 2 ways you can think of this. You can think of this as a -5. So you're going to go -4 times a -5, which would give you a positive 20. Or another way that you could have thought of that is you could have brought down the minus sign and thought -4 times 5 gives you a -20. Then you end up with the double negative, which you then change to be a positive like this one up here. So this has to be your final answer here, but you could start with that double negative. It kind of depends how you think of it. I think it's easier to go here and think this is a -5. So -4 times a negative would give you a positive 20. Okay, so either way that you can get to that positive on there is great. Okay, sometimes they like to switch up how they write your distributive property. So what if they have -2n plus 1, but on the other side they have, I don't know, maybe a -3. So notice they have the -3 in a parenthesis. They do that to make sure you realize the negative is with the 3 and it's not a -3. So they want you to see the parenthesis times the parenthesis, so you are still timesing, but your number, instead of being in the front, is at the end. You still can simplify, but it's kind of going backward like this way, and you multiply it again by both terms. So to get our answer here, I'm going to do -3 times the -2n first. So again, a negative times a negative would give you a positive. So we're going to get a positive 6. And then we're going to keep that n. Okay? And then -3 times 1 is going to give you a -3. So here we got 6n minus 3. All right, and that's our simplified answer. So could it have to go backward? Then they show you a couple with like just kind of thinking of why we would use this in mental math. What if I have all numbers, so no letters involved in this one? So I have 7, and we're going to times it by the parenthesis of 3 plus 10. How could I do that in mental math? Well, in mental math, you could think, well, 7 times 3 is 21, and then the 7 times the 10 is 70. Bring down that plus sign, and then I add them this way, and so 70 and 21 is going to give you 91. So sometimes we like to think about breaking up numbers in order to multiply them and add them in our heads. So this is distributive property mental math kind of idea, and you'd have to have pretty basic problems to be able to do them in your head. And the book gives you the Holt textbook, that's purple, Larson one, gives you quite a few examples of that. Okay, so then what if we had to combine like terms? So let's look at what if I had something like this? So I kind of taking out the distributive property of this one, plus 4 plus 7x. Okay, what if I have something like this? I have to look at it and they're all being added, but you can really only add things if they have like terms. And what like terms means is it means it's the same letter with the exact same exponents. So on this one, we have a 2x and we have another x, which is a 7x. So we can actually combine those terms by adding the numbers in front, because everything's adding. So 2 plus 7 would give you 9 x's. Okay, and then you still have this 4, which you can't combine with anything because there's no other, just numbers with no letters. So you write it next to it. So 9x plus 4. I cannot combine a 9x with a 4. So we're done. So that's how we're going to simplify with like terms. And let's see how this, let me clear my board real quick. Let's see how this relates to distributive properties. So what if, this is my second one in this, I don't know, maybe called the first one, I erased my numbers. Second one in my like terms idea. Okay, what if I had something like this? What if I have x minus 5? Well, actually, let's do plus 5 first. And then maybe I have a 2x minus 4. Something like this. So here is where we might have to use that idea of like terms mixed in with this distributive property. So first things is, when you have something like this, it doesn't have an equal sign, so it's still an expression. So we're going to just simplify it. So the first thing we're going to want to do is times that 5 by both terms. And that's going to get rid of this parenthesis. So we're still going to keep this x, bring down this plus sign, and we'll start with 5 times 2x, which would give us 10x. Then we're going to go 5 times, think of it as a negative 4, that's going to give you a negative or a minus 20. Okay, so my first step, get rid of the parentheses we use in distributive property. Now I look, do I have like terms? I do. I have an x and a 10x. They're both positive, so we're going to add them. Think of this as a 1x or x. 1x plus 10x would give us 11 x's, and then we keep that minus 20. Right? So there's kind of the distributive property mixed in. Let's do one with a minus in it, because these ones are hard. So what if I have p minus 2 times 3p minus 3 plus 2, something like this. Okay, so again, this is a big expression because it doesn't have any equal signs in it, and we're going to simplify this the best we can. So we're going to start with leaving this p here, and then we're going to start with a minus 2. Think of this as a minus 2. That's confusing a little bit, but minus 2 times the 3p would give you a minus 6p. Okay, so we're going to distribute and get rid of the parenthesis. And then again, think of this one. So the minus 2 times this 3, it's like a minus 2 times a minus 3. Or again, you're going to end up with a double negative in there. So that's actually going to give us a positive 6. Okay, and then we still have this plus 2. So notice I brought everything down, the p at the front and the 2, I just brought those straight down, and I just simplified using the distributive property in the middle. Now I look at what can I combine? Well, I have two p's. I have a 1p and a negative 6p, or 1 minus 6. Either way you want to think of that. So if I have 1 and I take away 6, I'm at negative 5 for p's. Okay, so that took care of those two p's. Now these are just numbers, so we can combine them because they're just numbers. So 6 and 2 make 8. And this is our final answer here. Some of the problems then take in the idea of perimeter, and so you'll have a shape and you'll have to add like terms for your shapes and different things like that. All right. So this is kind of going over combining like terms and distributive property.